I have never seen a pool like it. This is the tale of how an experiment with 2 tanks, some pipes and bubbles in the UK led to the most amazing pool being made in Australia. 4 years ago I set up a demonstration on how you can make an organic pool with separate planted and swim zones, just with some pipes and bubbles to circulate the water. Following that, Justin from Australia approached me for some advice, and he went on to make this most fabulous pool. For me, this project pushes so many buttons. As well as having a separate planted and swim zone, it's made in a hot climate and the whole thing is totally off-grid. Justin has had many setbacks, including filling the pool with dubious dam water, but he's overcome all of these issues and is generously sharing his experience with us. And I'll put my original film at the end by way of a reference, although it doesn't stand up to Justin's quality. I have learned such a lot from this project. And I'm sure, like me, you will find Justin's film fascinating.
Our family really enjoy living off-grid, so we live on a small acreage near Lake Macquarie, which is just north of Sydney, Australia. We were really interested in building an organic pool because it fits into that philosophy. We're very attracted to the idea that the organic pool is very efficient on the electricity and a very good user experience as well. Like, it feels amazing. We've spent many hours going through David's videos and modelled our whole system of his process. It certainly was challenging at times, and I lost a lot of sleep over some of the challenges that we faced. We also got a lot of value from other YouTubers and other content creators sharing their ideas. And some of the challenges that we encountered, I guess, we would like to share and give some of the solutions we had to some of our challenges. My number one piece of advice for someone embarking on a project like this is don't make any assumptions. So David is based in the UK, working with UK materials, the UK climate, UK flora and fauna. We're in Australia. All of those things are different down here. And so for that reason, it makes sense to try on a small scale and to make sure you really understand what you're working with locally and using the general principles of the organic pool that David has, which worked very well, but making sure you contextualize it to your local environment. The main constraint we had here, and the main reason that we actually went for a separate pool or swimming area to planted area, is because we were building on a slope. So you can sort of see with the continuity of the house and the courtyard, we wanted the pool to be on the same level, but the ground slopes away. So it turned out that making it all out of concrete was going to be very expensive. So we ultimately installed an off-the-shelf pool shell. Now this is designed to basically be semi-in-ground, this pool shell, and it's got struts to support it underneath. It's designed specifically for that purpose. And it's the same concrete slab that these IBCs are sitting on that. All of the plumbing, which is experimental, in between the IBCs and the pool, we can access now. So if it didn't work for whatever reason, it's not concreted in, it's not in the ground, it's all accessible underneath this flooring which you see here, which can be removed. And that was key because I didn't know what I'm doing. It's all an experiment. And so we wanted the plumbing to be accessible in the event that we needed to change the configuration. And we did need to change some things, so I'm glad we built it that way. This pool shell we just bought from a pool supplier in Sydney. That was about $20,000. And these IBCs are basically second-hand, and they're only $10 each. And the advantage of those is they've got a frame, they're self-supporting, sealed as well, and so it's quite an economical approach as far as raw materials. At that end of the pool, you can see that there are 4 black, they're outlets, so they're currently turned off. In behind there's 4 bubble pumps, which we'll look at in a moment. And that's drawing water from underneath all of these IBCs into that end of the pool. And those returns that we can see just here is where the water flows back into the IBCs. We have 2 skimmer boxes over here to filter the surface debris. That goes into the skimmer boxes, and then again bubble pumps bring it back around. And we also have a David Pagan Butler designed washing machine filter on that side. Here we can sort of get a picture of the plumbing. You can see here we've got 2 key manifolds. This is the outer or left hand, if you're looking away from the house, bank of IBCs, and they're running in parallel. So this is the manifold that comes from the outside end of the pool that returns the water into the top of the IBCs. And so you can see These IBCs, this is a 50mm standoff offset from this main manifold, and that's in parallel feeding water from the shallow end of the pool into the top of all of these IBCs. What the water will do is it will come back into the top there, it will pass down through the IBCs and then come back there into the other end of the pool. So the water is coming this direction in this manifold and back up into the IBCs, and it's coming out of the bottom of the IBCs and going back to the other end of the pool. So the water is cycling from one end of the pool to the other end of the pool, coming back into the tops of the IBCs and then back out that way. The actual layering in here is important. It uses the same as David Pagan Butler's system, but you have the planted area, which is water, and the water level in behind here is just above the bottom of this, the water level is above the top of that outlet. Then we have the water, then we have sand, then we have geotextile fabric, and then we have aggregate. And in the bottom of the aggregate, we have a coil of slotted drain coil, which feeds into there. And so the water goes down through the biological filter, through the geofab and the gravel, and then out there. The other advantage of using these IBCs, we can go around and turn off all of these valves, and we can put plugs in here, and so we can work on the system independently if there's a problem. And we had lots of problems that we had to deal with, and it was really handy to be able to isolate all of the IBCs, and even some of the IBCs when we were working on them, to be able to solve some of those challenges. It was also really useful to be able to drain the system, and so we had to retrofit them, as you can see here, but I'd definitely recommend being able to access and drain your manifolds if you're going to go down this path. The other advantage to this approach that we have here of having the slab and everything sitting on the slab is that these manifolds, which get quite heavy with all of the water in them and are accessible, are all sitting on a stable slab while still being accessible. As water is being drawn by the bubble pump from the bottom of these IBCs into one end of the pool, the water level in the pool rises a little bit and the water level in the IBCs drops a little bit. The return water is flowing back in based solely on the height differential of the water between the pool and the IBC. So there's no pump returning it, it's just relying on gravity. Another key point here to mention is the diameter of these pipes. So you can see we're using a 100mm pipe for the manifolds and 50mm pipe for the standoffs. The benefit you get with bubble pumps is that they are very high flow but very low pressure. And so I would highly recommend 100mm pipes, because even though a traditional pool uses 50, they have these high pressure water pumps forcing water around. Bubble pumps are not high pressure, but they're high flow. So you need to use much higher diameter pipes in order to get the flow, especially on the return side where it's simply gravity feeding it. It's very important to use large diameter pipes. So this is our general service bay area for the house. And this is the bubble pump that we sourced from a local septic supplier that is driving the pool. And you can see that this is going again into a manifold with 4 valves. These are air pipes that are going through to those 4 black bubble pump outlets. And you can see we've got valves to allow us to control the flow rate of air going into each of those separately. So this is a 100 litre a minute 70 watt air pump. We inject air at a depth of just about 2 meters, which we'll talk through. My calculation is that we are pushing about 30,000 litres an hour of water through the system based on only 80 watts. Now we live off grid and we have this thing turned on 24 hours a day, and the total volume of water in the pool and the IBCs we estimate to be approximately 50 to 60,000 litres of water. And based on that, we estimate that at a minimum, we're cycling the water multiple times per day. So not only is it very efficient on electricity, it's also extremely quiet and you can't even hear it. The reason that you see here the different settings that we have here is because the outer 2 are driving the flow rate through all of the IBCs, and the middle two are driving through smaller filters on the other side. So we actually intentionally use less air in those bubble pumps because we want most of the air and most of the flow associated with the IBC biological filter and less of the flow associated with the drum filter, which we'll talk through, and that's the reason that these have less air going through them than the outer ones. Here we have the bubble pumps. So there's 4 in total. Again, the outer 2 are drawing from each of the 2 rows of IBCs, and the inner 2 relate to the 2 skimmers and the washing machine filter. You can see where the bubble pumps are going. There's actually large 250mm or so pipe that goes another probably 1.5 meters or so down. David has some good videos on this in his channel. The deeper you can inject the air, the greater the flow rate. The way that we're injecting air is simply by these pipes, but we don't even have any bubble stones on them. All we have here is the pipe continues down on this one side, and near the bottom of the U, but still on this side, we have an end cap on the pipe, and we have a series of, I think they're 1mm holes, and injects air at the bottom of this pipe. That air then comes up the pipe, and this is sealed here, or close enough to sealed, and so the airflow and the water flow gets drawn out into the pool, and we get quite a substantive flow rate from that. You'll also notice while we're here, we had a problem, and this is one of the problems you'll get with these systems, with airlocks. And so what that means is when we drain the water out of it to maintain it or to work on it or to fix things or whatever it might be, we end up with an airlock. In fact, no water was even flowing through based on gravity, and we thought that related to the fact that we'd somehow clogged the system up with sand that was getting past the filter or some other problem like that. But in the end, it turned out there was nothing at all in the pipes. We even sent cameras down the pipes, and it turns out there was no blockages at all, and it was an airlock. Because we're dealing with low pressure, the bubble pumps, again, I can't underscore this enough, you cannot treat them like a normal impeller pump in this system. Anywhere there's a hump in the system, you will get an airlock, so you have to put a riser, and I'll also say you can't use the standard airlock release valves from a plumbing department because, again, they rely on higher pressure. Definitely the biggest challenge we had was the media that we put inside the IBCs. It turns out that aggregate supplies in Australia, certainly in our area, and my understanding of other areas, is that it's not washed aggregate, and the quarries that they come from end up being quite dirty because the use case isn't really for filtration, it's more for civil work, and certainly it must be related to the Australian environment such that it's really dirty. And nevertheless, we washed it. In the truck and elsewhere, we spent ages washing the aggregate, but nevertheless, as soon as we put that in and turned the system on, it went just opaque, and so much silt, you couldn't see it. It clogged up the filtration system as well, and the whole thing ground to a halt. The learning out of that was, well, what media do we use? And how do we resolve the fact that we now have water in the system that is so dirty, and how do we desilt it? This pool is such that because it's semi in ground, we can't just remove the water from it. It needs to have the water in there for the purpose of the structure, at least at the bottom level of the pool. So we can't just remove the dirty water. And secondly, we're on tank water here, and it's actually very costly to bring in water, especially if we want to bring in spring water, because we didn't want to put chlorinated tap water into the system, nor did we want to wait for enough rainwater to fill it. So we, for all of those reasons, really wanted to retain the dirty water but clean it up. So the question is, how do we clean up the really dirty water, and what do we do about the media? So firstly, as far as cleaning up the dirty water, we came across this idea of using a biologically safe flocculant to remove the dirt. And the way that flocculant works is that it's designed to take the particles and clump them together, and when they clump together, they fall to the bottom. And the idea being, you flocculate, all of the material floats to the bottom, and then you vacuum the bottom of the pool to remove the sediment. It's super important that you understand the role of pH, because the flocculant is extremely pH sensitive, and we had to dramatically move the pH of the pool in order for the flocculant to work. We had to change the dose we were using and the type of flocculant we were using. And the third thing is mix. The amount you mix in also has a material impact on the flocculation. So we ended up doing many hours and many jar tests inside and dosages until we eventually got to the place where it worked. Once we got the flocculant working, we then ultimately used a siphon system to remove all the flocculant out of the pool, because one of the advantages of being on the slope is we could use a siphon system, and so we used a standard pool vacuum to remove the flocculant from the bottom of the pool out, which meant that we still needed to top up the pool, but we didn't need to completely replace all of the water in the pool. So it took us a long time to figure out how to use that flocculant, but ultimately you can see the contrast between the water we have here now, which is majority the same as that dirty water, and the comparison now, and I guess that's the power of the flocculant when you understand how to use it. Then when it comes to the actual filtration media, it turns out that in Australia you can buy both sand and aggregate that's specifically designed for filtration. There's a couple of key suppliers in Australia for this material. One is from the Logan River in Brisbane, a big supplier up there, and another one where they do a lot of these systems in Adelaide. So we had to manually remove by hand all of the sand and aggregate from all the IBCs and then replace it with the new sand and aggregate. When it comes to the actual plants themselves, given that we live on a bit of a rural property, we have a couple of dams. Many of these plants actually came from our dams. So we have a permaculture consultant that we use. That's Lockie from Tree Frog Permaculture in Newcastle. But when we put the plants in, the pool initially went opaque green. You couldn't see through it at all. So we went from a problem of silt where it was brown and you couldn't see anything to a problem where it was completely green with algae and you couldn't see through it. And I lost a lot of sleep over that. But I kind of just put it on pause for a week or two. And then I was walking up in my hallway looking out at the pool one day and I was like, that looks a bit clearer. And I thought, well, I'm just going to leave it. And within a few days, a week, couple of weeks, it went crystal clear. And so obviously, and that was just as the plants were establishing. And so I'm actually really glad that happened, because it proved to me that the plants are actually there was obviously introduction of biology, but as the biology established and the plants established, they consumed the algae and it went crystal clear. And what you're seeing now is months and months later, total water clarity entirely from the biology and from the plant filtration. You can actually see there is some what's called string algae in there. And so we've since put some additional plants in that process those nitrates as well. So just one comment on this roof structure and the way it relates to the pool. Ideally, you don't want to have water from the roof directly going into the pool. David always recommends, as do we, a first flush system. We figured with this, it's a small roof and we just decided to take the risk, so we do have the water going straight, so when it rains on the roof, and it's actually quite nice, so when you get a short downpour you end up getting a waterfall into the pool, so that keeps the pool topped up, and we have an overflow system. When the pool gets too high, it overflows out the back. We really like the separate planted zone to the pool zone. It kind of does create a nice space. You get the same feeling of the pool and the organic water with a separate planted zone, and we're super stoked with the result. So just to sort of prove the point, we're going to have a bit of a drink from the pool. Tastes amazing. Now we're going to go for a swim. So my wife is the main one who actually wanted a pool to start with. So I asked her, what's your view? How's it to swim in the pool?
It's amazing. You don't get the yuck of chlorine in your eyes and on your body. And because we've got the bubble pumps, the water is so aerated, it's just so light feeling.
So I just wanted to give a huge thanks to David for his support, and we watched over and over many of his videos to to construct this, and we're super stoked with the result, and everyone who's been in the pool is super stoked with the result. So it does work. Also a big thanks to Lockie Borges from Borges Building, who did all the physical construction for us. He did a phenomenal job, and obviously being totally bespoke, he was really flexible and really appreciated his great work. And also Lockie from Tree Frog Permaculture, who assisted us with the planting and maintaining the biological balance. So it is a bit of a team effort, and as I said, we're super happy with the result and can't recommend this kind of pool highly enough. Thanks again to everyone else online who posts content that assists with these kind of projects, and hopefully this has helped to give back to the community as well with some of these ideas.
Hello, I'm David Pagan Butler. Now, I've been asked the question, is it possible to have a separate swimming zone from the planted zone in an organic pool? Now, an organic pool normally has the planted zone all the way around the outside and the swim zone in the middle. This greatly simplifies the construction and also makes it really beneficial for wildlife. However, there may be circumstances where having a separate swim zone from the planted zone is really beneficial. So I've mocked up a situation here where this tank is representing the swim zone and this one the planted zone, and we've got the water circulating between the two just with the use of airlift pumps or bubble pumps. Now, the swim zone, what's happening is water's being drawn in from the planted zone via a pipe down there, and this is filling up to a particular level, and when that reaches a level of the exit drain, water then drains into the planted zone, and this circulation is what is filtering the water. Now, in the planted zone, I've represented the plants with plants. But here you see I've used little floating islands of plants. The more wild looking one is just lifted off a paving slab that was around the edge of the pool, and the plants have been growing on that nice and neatly, and I've just put a piece of wood underneath just to give it a bit of buoyancy, and those plants have been sitting there quite happily for a week now. And this other one, this high-tech one, I've got some insulation offcuts from a DIY project. I've drilled in a 3-inch hole and pushed in some plants. This is mint. So this is actually one valid method of using plants to filter water. So this is probably the simplest method to show how you can separate the planted zone from the swim zone. So I hope you've enjoyed this little film, and see you next time.